Question number 35, book Pathfinder, chapter kinematics, subsection check your understanding. Stone is projected from the ground with a velocity 10 meters per second and its trajectory is drawn to an unknown scale on a graph paper. The horizontal range and the maximum height of the graph are 1 meter and 0.25 meter respectively. The graph paper is glued on a horizontal tabletop. If an insect moves along the trajectory graph paper with a uniform speed 1 centimeter per second, what should be the modulus of its maximum acceleration be? And acceleration due to gravity is 10 meter per second square. Okay, so this is the path of stone. Let the maximum height be h and the range be r. And on paper, it is h is 0.25 meter, and actually the height may be some k times 0.25 meter. So the k is the scaling factor. So actual height is k times the height shown on paper. And the formula for the maximum height we know is this. And similarly, the range is k times 1 meter. 1 meter is the range drawn on paper. Actual range is k times of that. So from these two, we get the value of theta as 45 degree. Now we know the radius of curvature is given by this formula v square over normal acceleration. Put the value of theta in the expression for h and find k. K is 10. Okay, so actual values are 10 times larger than the values shown on paper. So this is the meaning of that. ROC is minimum at highest point. We know that this expression v square over normal acceleration, this is minimum at highest point because the speed is minimum at highest point and the acceleration, full acceleration, that is gravity, that is normal acceleration. So if you compare ROC from point of position to the maximum height, so see what's happening. Speed is maximum at the point of position, while normal acceleration is only a component of gravity in the normal direction. So that will be smaller than gravity. So what is happening at the point of position, this V is large while AN is small, so the whole thing becomes very large. This ROC is minimum at the highest point because there the speed becomes minimum and full acceleration, that is gravity, becomes normal acceleration. So ROC is minimum at highest point. And if you find ROC at highest point, in the actual case, it comes out v square over normal acceleration. So highest point, at highest point, velocity becomes u cos theta. U is the initial velocity and cos theta. So initial velocity is given as 10 meter per second and theta we have found 45. So 10 cos 45, that is 5 root 2. So v square upon normal acceleration is equal to g at highest point. So that is 5 meter. So this is actual. And what is ROC on paper? On paper, everything is 10 times smaller. So on paper, ROC will be 0.5 meter. Now, on paper, there is an insect moving with a uniform speed. So when the insect is moving with uniform speed, it's having only normal acceleration. There is no tangential acceleration. Okay, so we have to find the maximum acceleration. So acceleration can be written as from this formula, ROC formula. So normal acceleration is v square over ROC. And for insect, insect has only normal acceleration. There is no tangential acceleration in the insect because its speed is constant. So its normal acceleration can be found by using the formula v square over ROC. Since v is constant, so maximum acceleration occurs when ROC is minimum. And on paper, we have found minimum ROC as 0.5 meter. So simply putting the values in this formula, we'll have maximum acceleration as v square over minimum ROC. V is given as 1 centimeter per second, convert into meter per second. And ROC minimum we have already found, just solve it. So that solves the question. Okay.